The greatest pleasure in life is to ask questions, said someone some time ago. Please don't kill me for not having an actual quote, but nevertheless, I don't know who said that, but the principle still stands. We, as observant humans, take in tons of sensory information every single day, and we see patterns and can't resist to ask ourselves about those things that we observe. So everything from why did those men fight that war 200 years ago, to why do I have self-consciousness and know who I am, to why does that gray mush knocking around in my skull up there understand what others are saying, to does coffee really make me more alert? All of these questions and more beg to be answered, because it's our greatest desire to ask them and get an answer and understand the world around us better. And luckily for us, we can answer them with the power of scientific research. But first, we must turn our questions into scientifically answerable questions, a hypothesis. And so today, we're going to start with that first step, formulating a testable hypothesis. We're going to cover two main things. First of all, how to form a hypothesis, and second of all, how to make sure that hypothesis is testable. So let's get started. Before we actually get our hands dirty in how to actually dig out a hypothesis in a question we have, we must examine the basic building block of every hypothesis, and that is a variable. Variables are things that vary among participants in research. But that's a boring old definition and we want to wave it away from our faces, so let's look at some examples. Luckily for us, examples of variables exist everywhere in the world. Stress levels are variables, religion is a variable, height is a variable, the amount of staplers you own is a variable, or the times you've broken your screen because you've wanted to punch Joffrey Baratheon because he's just asking for it is a variable. Sorry, got a little carried away there, but all of these are variables, because they are things that change from person to person. And so a hypothesis, our main topic today, is built from these variables. More specifically, a hypothesis is a prediction of the relationship between two variables. These two variables, we call them a dependent and an independent variable. As per the name, the dependent variable depends on the independent variable, and this will be made clear when we start talking about actual examples of hypotheses. But before we examine that, we must look at the other part of a hypothesis, which is the prediction of a relationship. And these predictions come in all shapes and sizes. We could predict that the next US president is going to be Kanye. In this case, our question could be, why would Kanye be the next US president? Or our prediction could be that a sugar high exists. We could ask, why does sugar make us more excited? Or meet Leslie Knope. She was a director of Parks and Recreation in Pawnee, Indiana, and she's often excited. Very often. So let's develop a prediction. Leslie's excitement increases with the number of waffles she consumes. This prediction could come from a question, why is Leslie so excited all the time? And this time, we have a prediction for our answer. We've decided to say that the amount of waffles she consumes, our independent variable, starts to change her excitement levels, which is our dependent variable. And the relationship here is that one increases and the other increases as well. Okay, cool. So now we have a pretty cool hypothesis. Very importantly, and I can't stress this enough, this cool hypothesis has three crucial and crystal clear elements: the independent variable, the dependent variable, and the relationship between them. We could also say that a higher amount of Twitter followers increases your chances of being the next US president, or that a sugar makes children become more active. These are all pretty cool hypotheses because they clearly identify those three elements. But we are pursuers of excellence, so we can't stop at cool. What do we do to make these hypotheses awesome? The answer to that question is that we must make sure our hypothesis is testable. That's what makes them awesome. And more precisely, we can ask two questions. First of all, is our hypothesis falsifiable? And second of all, how can I measure my variables? And so let's start with our first question. Is this falsifiable? Here, simply ask yourself, can my hypothesis be proven wrong? Many of Freud's ideas, for example, are unfalsifiable. If you reject the notion of an id, Freud can just tell you that it's your repressed urges that are telling you reject that idea because it hides some of your deepest, darkest childhood secrets. And so at the end of the day, Freud's theory can always outfox you at every turn and say, what you just said is actually supporting evidence for my theory. There's no way to prove his theory wrong. And so as this demonstrates, unfalsifiability, number one, doesn't necessarily mean that a theory is unworthy of our examination. But also, unfalsifiable hypotheses are basically worthless when it comes to scientific research. Why spend your time researching whether something is false when it can't be false to begin with? Now, on the other hand, we must also know how we're planning to do our research. That's our second question. And to help here, we can also use operational definitions. This is very important. Note this. Operational definitions define your variables through how you will measure those variables. Take Leslie as an example again. We have hypothesis with Leslie's excitement as our dependent variable and the amount of waffles as our independent variable. Identifying how to measure these is extremely important, and actually take a second to think about that. Okay, your second is over. I chose two main ways. So I chose to develop a 5-point scale for Leslie's excitement and let professionals determine how excited she is. And on the other hand, I would just count the amount of waffles she ate in one day. But you could have many different ways to measure both of these variables, and as long as you specify them, you have a pretty good operational definition. We'll talk a bit about the significance of having a good operational definition in a later video, but just for now, understand that these are extremely important to start with because you at least will understand how you're going to measure what you're going to measure. Alright, so now you have a fully fledged hypothesis. To recap, we began with variables, which can be anything that changes among our participants in research. A hypothesis contains two different types of variables, a dependent and an independent. The dependent variable depends on the independent, and a hypothesis specifies the relationship between the two of them. Leslie's excitement increases the more waffles she eats is a hypothesis with all three of our crucial elements. We then ask two questions to make our hypothesis awesome. 1, is this falsifiable? And 2, how will we measure each variable? And ta-da! We have a hypothesis. Well done. I will see you in the next video.